Okay, we are going to be adding and subtracting rational expressions, and just like adding and subtracting fractions, which we're doing, you still have to find a common denominator. So unlike multiplying and dividing, which we just did, there's no need for a common denominator. You multiply straight across. So before we get into the lesson, I want to just give a little reminder, adding and subtracting fractions. Let's say that I have 5 over 12, and I want to add it to 4 over 15. So what you have to do is find the least common multiple, or least common denominator, of 15 and 20. So you have to look at each one of the factors. So 12 has 4 and 3, and 15 has 5 and 3. And what we have in common here, they both have a 3, so we don't need to change anything here. But this fraction has a 4 but not a 5. This fraction has a 5 but not a 4. So we're going to multiply by what's missing on the top and the bottom, because we're going to multiply by 1. 5 over 5 is equal to 1. And on the other fraction, we're going to multiply by 4 over 4, which is also equal to 1. So we haven't changed its value, we've just changed its look. And so when we multiply all that through, you get 25 over 60. And you also get 16 over 60. And we are going to combine these two, and that gives you 41 over 60. And we have added the two fractions. Now we're going to change this up a bit. We're going to be adding variables and factoring to this. And so let's go ahead and move on. Alright, we're going to add these two fractions, and first of all what we have to figure out is what they have in common and what's different. This one is 3x, this one is 2x squared. Now this fraction does not have this 2 in the denominator, and it's all about the denominator. It's also missing an extra x squared, so we'll be multiplying both sides there by the 2 and the x, because the common denominator we're going for here is 6x squared. You want to go for the largest exponent for your common denominator. So I'm going to multiply 2x over 2x times my first fraction, and I'm going to multiply 3 over 3 by my second fraction. And when we multiply these denominators, that gives me a 6x squared, and that gives me a 6x squared, which is my goal right there. So we'll have 4x over 6x squared plus 9 over 6x squared. And now we can add these together because they have the same denominator, and you don't change the denominator now. And then you'll have 4x plus 9. And that's as simple as that one's going to get. Alright, now we're going to subtract. And what you really have to be careful for is distributing this negative when we get around to this. Now, each one of these denominators has its own unique factor, x minus 4, x plus 2. You can't consider the x's in common because they are added and subtracted by a number. Each one of these is their own factor. So your least common denominator here is x minus 4 times x plus 2. The least common denominator is a product of factors. You can't have a bunch of terms added. So we're looking at a product of factors. So what the first fraction is missing is x plus 2. So we'll say x plus 2 over x plus 2. And then x over x minus 4. Second fraction is missing x minus 4. So we're going to go x minus 4 over x minus 4 times 3 over x plus 2. Now I'm going to go ahead and combine these. One denominator, the denominator is now common. Do not FOIL the denominator. It does not make it more simple. It makes it more complicated. So keep your denominator factored. Do not multiply it. I'm going to multiply x plus 2 times x. That you do want to multiply. So you'll have x squared plus 2x. And what you need to be extremely careful of with subtraction is that whatever multiplies here, you're going to change all the signs. So for right now, I'm just going to write a minus, and whatever I multiply goes in the parentheses. Alright, so what I end up with is 3x minus 12. And then I'm going to combine like terms and distribute that negative. So I'm going to have x squared minus x plus 12. Now what you might notice when you get to this point is that maybe you can factor that numerator again, and I would recommend trying that. So if you are able to do that, you can try, but there aren't factors of 12 that will add up to be a -1. So at this point we're done, but sometimes you can go ahead and refactor and see if you can cancel again and write it even more simplified, and that is something that you should do. Okay, so what should you do here when you have a trinomial in your denominator? The first thing you should do is go ahead and factor it, and I like to just, instead of rewriting the entire problem, I like to write it right underneath. So x minus 3, x minus 1. So what I see that they have in common is x minus 3. They both have an x minus 3 as a factor in the denominator, but the one on the left also has an x minus 1, so that needs to be included in your least common denominator. So what happens here is that this x minus 3, x minus 1 is the LCD, and this one has both of them already, so the first fraction doesn't need any change, but the second fraction does. So we're going to multiply the second fraction by x minus 1 over x minus 1. So here's my 5 over x minus 3 times x minus 1 over x minus 1. And I'm going to go ahead and write this as one large fraction. So x minus 3 times x minus 1. No changes for the first one, and we're adding, so we don't really have to worry about signs now. So 5x minus 5. And we'll combine like terms, and you get 6x minus 5 over x minus 3, x minus 1. And don't FOIL it, leave it like it is, it's fine. Okay, so the last one, we've got two trinomials, they are different, and we need to factor each one. So the factors of 12 that will add up to be a 1 are 4 and 3. So I'm going to have an x plus 4 and an x minus 3. And the factors of x squared minus 2x minus 3 are going to be x minus 3 and x plus 1. So what I see that we have in common here is an x minus 3, right there, and the things that are different are x plus 4 and x minus 1, and that's going to be my common denominator. So, common denominator x minus 3, x plus 4, x plus 1, and do not FOIL it. Leave it alone. It's happy. Alright, so what we are missing here, and I'm going to go ahead and make one long denominator. We're going to do a little step combining here. And a note about that, only combine the steps as you're comfortable. If you're not comfortable, add more steps in. But what I know is that x minus 2 here needs to be multiplied by x plus 1. I've already got it on the bottom. So you're going to multiply it by what's missing. So I've got x minus 2. Going to multiply it by the missing x plus 1. And then I have x. And I'm going to multiply it by the missing x plus 4. And writing like that perhaps will help us remember to distribute the negative as we multiply the x. So let's FOIL the top only, do not FOIL the bottom. So in your denominator you've got x squared minus x minus 2 minus x squared minus 4x. Denominator x plus 4, x minus 3, x plus 1. I would not FOIL the denominator. Do not FOIL the denominator. And then I'm going to combine like terms. So what I see here is that the x squared subtract out. And then I will have a negative x and a negative 4x. Gives me a negative 5x and then minus 2. And then over all of this. And that will be your final answer. Always do check and see if you can refactor your numerators, because sometimes you are able to cancel. And so that's always a very good idea, so that you can see if you can simplify it even further.